Now let us understand a very important category of questions within permutation and combination, and we call it a category of partition. And the rule which we use to solve such questions is called stars and bars method, right? So the questions from this particular category can be framed in variety of way. The only thing what we do in each of the question is that we try to manipulate the question itself so that the method which we will learn in some time can be applied, right? So to understand that method, let us first of all take the things from the very basics, and let us do or let us solve the very first questions without using that method, because the very first question is too rudimentary and we can solve it without using any kind of method. It is very simple. Now what the question says, let us understand it. Now it says that in how many ways 8 identical apples, that means the things which we want to distribute is identical, can be distributed between two children. So it's obvious that the two children will be different, right? And no other information is given. Hence, we can assume that it may happen that a child, say if I take the two childs to be say child 1 and child 2, a child can get the entire 8 apple, right? And the other child can also get the entire apple, but definitely these two things will not happen simultaneously. So suppose we want to distribute and we got the responsibility of this distribution, then what we can do, we can straight away go with the simple counting logic, and we can say that it may happen that the first child will get a 0 apple and the second child will get the entire 8 apple. So I can say 0 8 is one way of distributing the 8 identical apples between two children, right? Now here the word identical is very important, because we are not distinguishing between two apples, right? The only distinguishing factor will be the number of apples a person is getting, or the child in this case is getting. The other way could be if I give one apple to the first child and the rest of the apple, that is 7 apple, to the second child. Obviously this is one of the possible distribution, and this is different than the previous one, right? Because in the previous one the first one is getting 0, in the second case the first one is getting 1, and similarly the second child is getting 8 and 7 respectively. We can go on increasing the number of apples which one gets. Automatically the number of apples which two or which the child 2 will get will keep on reducing. The only thing which will happen every time is the sum of the apple has to be 8, right? So the next, if I want to list all the possibilities, then it will be 2 6, then 3 5, then 4 4, then 5 3, 6 2, 7 1, and 8 0, right? Now important thing to note here is that 3 5 and 5 3 are two different distribution, because here the people or the childrens are different. So the first child getting 3 apples and second child getting 5 apples is different than first child getting 5 apples and second child getting 3 apples. So here the order is also very important, right? So if I list all these things and then if I want to think about is there any possibility, then definitely I can say that there is no further possibility of distribution. So I have listed all the possibilities, and if I want to count, then it is counting from 0 to 8. So overall possibility would be 9, or I can say the answer for this question would be 9. That is, there are 9 different ways of distributing 8 identical apples between two children. Now this is very simple question. Obviously this distribution between two children is seldom comes into the competitive exams. The number of people to whom we want to distribute is obviously greater than 2, and that's why I have taken the second questions. So if I look at the second question, then it again say that then we have to distribute 8 identical apples, and now the number of children is 3. Again we can make the similar kind of table and keep on distributing. The only difficulty would be that now the number of cases would obviously be more, and there is chances that we might miss some of the cases, or if we don't go in a logical order, then it might happen that we will repeat some of the cases. So the possibility of getting wrong answer by this particular approach is too high, as well as the effort it will take will be too high, right? That's not worth giving effort to solve this way. So definitely there must be some alternate ways. So let us come back to question number 1 again, and let us try the method of partition or star and bar method, right? So the method which we are discussing here is called stars and bars method, right? So In this case, what happens is that suppose if I want to take eight identical apples, so let me assume that this is the eight identical apples. So these star will represent the apples. So let me just count it. It's obviously, yeah, it's eight. Now we are right now we are discussing the first question only, right? So we have to distribute eight identical apples between two children, and we got the answer to be 9 with this particular approach, right? Now let us see that by this bar and star and bar method, can we get 9 also, and how do we get 9, right? So what we do here is that since we want to distribute these apples between two children's, then what I can take is that I can take one partition, and suppose if I place the partition like this or a bar like this, right? Now what this particular bar has done, it has divided the eight apples into part. One, the number of apples which is on the left side of the bar, and the number of apples which is on the right side of the bar. So if I count them, then it is 5 and 3. Now 5 and 3, as we can see, is one of the possibilities which we have listed here. Similarly, we could have placed this bar, say at a position, say like this. Then in this case, the number of apples on the left hand side would have been 2, and the number of apples which is on the right hand side would be 6. Now 2 6 is the possible one of the one of the possible distribution, as we can see. Now if I look at another possibilities, then we can say that if I just remove it, then if I suppose substitute or put the bar at this particular place, then we can say that the left hand side is entire 8 apple, and on the right there is no apple, so we can assume mathematically that they are 0 apples. So 8 0 is also one of the possibilities. So we can see that the as and when we are putting these bars at different places, we are getting different numbers of distribution, right? Now one thing which we need to check is that is there any possibility wherein we can get the same distribution by placing the bars in multiple positions, right? For example, suppose if I want to say get the distribution, say 6 2, that the first child should get 6 and the second child should get 2. Is there possibility more than one by using this star and bar method? So if I take, let me just rub this. So if I want to distribute or divide this particular stars in 6 and 2, then I have to keep 1 2 3 4 5 and 6 number of apples on the left hand side. So I have to substitute bar at this position. Now it is quite obvious that I can't have any other position for this bar if we want to distribute in 6 2. That means the number of possibilities, that means there are no possibility of getting more than one way of distributing or getting 6 2 distribution by placing the bars over these positions or the positions or the gaps which is between the between any two stars, right? Now, so what we can derive from here is that the different position which this bar can take will give me the corresponding different number of ways to distribute these 8 apples, right? So let us see how many different positions we can have to place this particular bar. So if I put the bar at this place, then the distribution will be 0 8, and if I put it at this place, then it will be 1 7. Similarly, if I put it at this position, then it will be 2 6, so on and so forth. That means the number of different positions where the bar can be put is 1 2 3 4 5 6 7 8 and 9. So there are 9 different positions where the bars can be put, and hence correspondingly we will be getting 9 as different number of ways to distribute 8 identical apples between two children. So I hope this particular logic of star and bars is very clear. We using a partition by using a bar to divide the entire set of these identical things into various groups. Since we need here only 2 groups, so the number of partition or the number of bars needed is only 1. Now let us use this method to solve the second question directly, right? We'll not be applying this particular method, we'll be applying this star and bar method directly to get the answer, right? So let me just rub this part. Again here I have listed all the 8 identical apples, and since we have to distribute this among 3 children now, so we have to make 3 groups. So since we have to divide into 3 groups, then the number of bars required is 2, right? It will always be, or the number of bars required will always be 1 less than the number of children's given. In the previous case, it was 2 children, so we need only 1 bar. In this case, we have 3 children, so we need 2 bars. So the number of ways wherein these 2 bars can be placed to divide this thing to three parts. Suppose one of the way would be, suppose if I put the bar at this place and set this place, then the first group will be all the number of stars which is on the left side of the first bar. So we can see that the first child should get 3 apples. Similarly, the next one will be between these 2 bars. So it will be again, the next child should get 3 apples, and the third one will be the right side of the second bar, that is 2 apples. So we can say that 3, 3, 2, this is one of the possible way of distributing 8 apples among 3 children. Now we have to identify that how many ways these 2 bars and these 8 identical apples can be arranged in different orders, right? So if I count the total number of things which we put it here is that there are 8 apples and 2 bars. So the total number of things is 10, right? So if I put 10 places, say 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, then the 8 apples and 2 bars need to be placed at this position, right? So out of these 10, if I pick any 2 places where I'll be putting the bars, for example, if I select these 2 positions where I'll be putting the bars, then rest of the position, or in the rest of the position, will be putting the stars, or 8 stars in this particular case, and hence we'll be getting one possible way of distributing it, right? So how many ways we can put these 2 bars in these 10 places? And obviously we have to select 2 different places for placing these 2 bars, and the number of ways is straight away 10c2, as we can see, right? So the number of ways of placing the 2 bars will be 10c2, and once we have selected the place for the bars, the rest of the 8 places will be filled with stars. For example, in this case itself, this place will be occupied with stars, this place will be occupied with a bar, this place will be occupied with stars, again this place will be occupied with a bar, and this place will occupied with a star. So the distribution is 4, 2, 2, right? Again, you can see this is different than the previous, and obviously one of the legitimate method or legitimate way of distribution, that is first child should get 4, second 2, and third 2, right? It may happen that both the bars will come together also. For example, suppose if I select, or if I put the bars as 1, 2, 3, 4, 5, 6, 7 and 8, and if I put the 2 bars like this, then this distribution is nothing but the first child get 3, the second child get apples between these 2 bars, so there is no apples in this between these 2 bars, then the second child will be getting 0, and the fifth child will be getting 5. So we can say that the answer for this particular question will be 10c2. That means the number of ways wherein we can put 2 bars out of the 10 places for 8 bars and 8 stars and 2 bars, right? And if I calculate it, then it will be 10 into 9 by 2, which comes out to be 45 straight away. So this has become a formula. So answer for this particular question is 45, right? Now let me give you the general formula for it. So general formula for these kind of question or partition or the star and bar method is, if there are n identical things which need to be distributed among r different things, then the number of ways of distributing them would be n plus r minus 1 c r minus 1, right? You can just take the simulation that if n is the apple, then r is the children. So if r is the number of children, then r minus 1 will be the number of bars. So the overall number of position will be n plus r minus 1, and out of it we are considering the number of position which we can select for the bars to be put, and rest in all other places automatically the stars will take its stars will be placed, and this different selections will give me the different number of distribution. So please remember this particular formula. This is very, very important. From next video we'll be using it extensively and directly as well.